Hi, I'm Timothy, and this is Michael. We're the team leads for Team DUCKZ at Stevens Institute of Technology, and these are our bots for High Stakes 25.
So to begin, for our drivetrains, this is a 450 RPM with 2.75 inch wheels, and then on the big bot,
this is 360 RPM. We went for a slower RPM to kind of aim for more power in the bigger bot, and we used 3.25 inch wheels to match the larger dimensions of the bot.
And then to talk about, so our main design components, or our main subsystems, are going to be the intake and our conveyor. For our intake, we have it rubber banded down. We found it helped us get a much better grip on the different rings for intaking. And then we also run our intake at the max RPM of 600, so it's just a 1-to-1 on our chain. Once again, because running it, we found that the faster we ran it, the better we were able to pick up rings. We also made sure to have our intake a little bit out front, in front of the robot. It just allowed us to be able to pick up rings off the wall a lot easier, to pick up rings as we're turning a lot easier, and just gave us a lot more like flexibility to pick up rings in odd scenarios. We also have these two like long pieces of C-channel, like 1x1s, or not 1x1s, but like these long lines of C-channel, which we use to keep the ring from popping out of place on the small bot. For the conveyor, we have it running at a much slower RPM, around 400, between 300 to 400 RPM. It made it a lot more consistent on picking the rings up from our intake. So just running it here, just allowed us to much more easily pick up our rings. And then we have a color sensor on both bots that you can see here that we use for sorting. So obviously, all we're doing is we're just basically reversing the conveyor for a quick second to throw off the wrong color ring if we're like blue team and we want to score a blue ring to throw off our red rings. And then on the big bot, some minor differences. The big bot comes off a lot farther off the front of the bot just because we didn't have to worry about design considerations. The small bot has that 15-inch limited size, and we didn't have to worry about that on the big bot. And then we also have some fabric that just allows us to once again prevent rings from flying off the bot. And then the final design that we want to talk about is we are using polycarb in a couple places to get really low to the ground on the big bot, as you can see if I lift it up here, to get really low on the ground. And then as also for our hooks on our conveyor, it allowed us to once again pick up rings off the ground really consistently, and also not flick rings off, and allow us to score consistently onto the Mogomex.
So in order to actually grab onto the mobile goals, we used a pretty standard pneumatic clamp. You can see here, driven by 2 pistons, and we just used simple standoffs as aligners in order to get the mobile goal to line up properly. You can see we put it in, we clamp down, and this is basically right in the perfect orientation to score a ring on using the conveyor. You can unclamp it. We also, you can see this standoff right here on the clamp was used to get the mobile goal at exactly the right angle. So a lot of trial and error just went into this to get it to score the highest percentage of the time. We also have a corner clearing mechanism, or a doinker here. So this is also pneumatically powered, and it's used in matches to clear the rings out of corners, because there's often times when you want to put a goal in a corner but there's rings in the way. We have very long vertical component that lets us touch all of the rings when we're clearing it out. You can see we are attaching it on both sides. This is very securely attached in order to make sure that this does not bend at all. We braced the corner clearer as well internally, so that this is the part with the highest chance of being hit into. We wanted to make absolutely sure that it would not bend or break.
We also used the doinker for autonomous period. Specifically, the small bot was used to grab the mobile goal in the middle of the field. So as part of our autonomous period, we would back up and use it to grab onto it and just grab it as we would back up with the robot. And that was like a main part of allowing us to win some of our matches, was to maintain control of that third mobile goal really quickly and early into the match. And also, one last thing to mention is we spent a lot of time on trying to make sure that our robot was easy to like work with, because we're a new team. So a lot of our design, we really wanted to maintain simplicity and just keep it really easy to work with, which you can kind of see in some of our designs, where it's very like, it's a very open robot in comparison to some other teams that you'll see. Thank you.
Thanks. Smile.